A quadratic equation has the form y equals ax squared plus bx plus c, where a, b, and c are constants, and a is not equal to 0. The graph of a quadratic equation is a parabola, which is a curve that is symmetric with respect to a vertical line called the axis of symmetry. Two examples of parabolas are shown on the coordinate plane. Let's look at each one in a little bit more detail. The purple parabola, we say, opens upward, and the axis of symmetry for this parabola would be the vertical line x equals 3. The red parabola, we say, opens downward, and its axis of symmetry would be the line x equals -2. The point at which a parabola intersects its axis of symmetry is called the vertex of the parabola. Notice that for the purple parabola, the vertex would be the point 3, -4. And for the red parabola, the vertex would be the point -2, 9. Now the vertex of a parabola is where the quadratic equation has either its least or its greatest y value. So it is sometimes called a minimum point or a maximum point of the equation. We can see that a parabola that opens upward, such as the purple one, has a minimum point, and a parabola that opens downward, such as the red one, has a maximum point. One method of graphing quadratic equations is to generate a table of ordered pairs. And we can do this by simply choosing some x-coordinates and then calculating the corresponding y-coordinates from the equation. Let's graph the parabola y equals x squared. We can begin by choosing 0 for x. Then y would equal 0 squared, which is still 0. So the origin, the point 0, 0, is 1 point on this parabola. Now let's choose x equals 1. Y would equal 1 squared, which is also 1. So we can plot the point 1, 1 as well. What if we allow x to equal -1? Well, -1 squared is also positive 1. So the point -1, 1 is on the parabola. If we let x equal 2, y equals 2 squared, which is 4. So we can plot the point 2, 4. And finally, if we let x equal -2, -2 squared is also positive 4. So we'll plot that point -2, 4. And now we can see the parabola beginning to take shape. If we connect these points to make a smooth curve, we obtain the graph of our parabola. Note that the vertex of this parabola is the origin, 0, 0, and the axis of symmetry is the y-axis. Let's graph one more quadratic equation by this method of generating a table. In this case, we have y equals -1/2 x squared plus 3. Once again, it's easy to start by letting x equal 0. And in this case, the first term of the equation would simply be 0, so we have y equals 0 plus 3. And so 0, 3 is a point on this parabola. Now, since the coefficient of x squared is -1/2, it would be easiest to work with x values that are even numbers. So next, let's choose x equals 2 and substitute that into the equation to calculate the y value. We would have y equals -1/2 times 2 squared, which is 4, plus 3. Well, -1/2 times 4 is -2, and then if we add 3, we obtain positive 1. So the point 2, 1 is on the parabola. Note that if we allow x to equal -2, we would obtain the same result, because -2 squared is also 4. So the y value, once again, would be 1. We can plot that point, -2, 1, on our graph. What if we allow x to equal 4? Then we have y equals -1/2 times 4 squared, which is 16, plus 3. -1/2 times 16 is -8. And then plus 3 gives us -5. So we can plot the point 4, -5 on our graph. And then again, if we allow x to equal -4, we should obtain the same y value, since -4 squared is still positive 16. So we can plot the point -4, -5 as well. And now we can see our parabola. Let's connect these points to make the curve. Note that once again, the axis of symmetry for this parabola would be the y-axis, and in this case the vertex is that point 0, 3, which is a maximum point. This parabola is opening downward. It's important to note that the reason this parabola opens downward is that the coefficient of x squared is a negative number. If the coefficient of x squared is a positive number, as we saw in our previous example, the parabola would open upward and then would have a minimum point instead of a maximum point.